Alright everyone, welcome back to the day 14 of our daily leetcode challenge, and today we've got find the prefix common array of two arrays. Now if you read all this, they have kind of made it confusing, but it's actually pretty simple. What they want us is, they have provided us with two arrays, and the length of the array is n, and both the arrays are having values from 1 to n, which is inclusive, which means they have values from 1 up till n, and both of them are in the array. So let's say that if the value of n is 7, then this would be the original array 1, 2, 3, 4 up till 7, and the two arrays that will be provided with will have values from 1 to 7, but they will be shuffled. So it would be shuffled in this format. This could be 1 and the other could be something like this. Now what they want us to do is that with each passing index, what is the count of values which is common in both the arrays? What is the count of values which is common in both the arrays? So let's take a look in this example. So if we are at the 0th index, what is the count of value which is common in both the arrays so far? So we see that array 1 has 2 up till here and 1 up till here, and they are no common values, so the answer for this index will be 0. How about when we reach up till index 1, which is the second one? So up till here we see that 3 is appearing in both, so the count becomes 1. We have one value which is common in both. Now let's see what happens up till here. Up till here we see that we have a 3 appearing in both and a 2 appearing in both, so the count of values which are appearing in both the arrays becomes 2. So we have 2 right here. Now what about we reach up to index 3? We see that the count of values which are appearing in both the arrays is 3, 2, 5 right here and 2, 3, 5 right here. So the answer for this index will be 3. Now what about when we reach this index right here? We see that the count is still going to be 3 because we have 1 and 7 entering, so it's going to be 3 right here. What about this index? At this index we see 6 appearing in both, and so far we had 3, so 3 plus 1, 4. 4 common values, which is 1, 2, 3 and 4. So these are the common values, which is 2, 3, 1, 6 and 1, 3, 2, 6 and a 5 as well. So I think this is going to be 5, yeah, 5. At this index it will be 5 common values. So having said that, this is what we are doing. We are basically, with each passing index we are checking, and also at the last index the answer will always be the length of the array, because once we reach the entire array, in both the cases we are going to actually carry all the values from 1 to n inclusive, because these two array are the permutation of the simple array 1 to n. So up till when we come up till here, it's going to be the length of the entire array, which is 7. So which is like 7 values here and 7 values here appearing, all of them are appearing. The count is same, so like 7 is going to be. So this is how we are solving this. So if you take an example, right, like let's say what I do is I define 2 sets for each array. I define 2 sets, and with each passing index, if we take the intersection of those 2 sets, it will give us the common values, which we are doing right here. This is what we are doing. We are basically doing an intersection and finding the common values. So in this another example, let's take this example. Let's say the value of n is 8 and we have arrays like this: 4, 2, 3, 1, 5, 7, 6. One value is missing, and that is 8. This is array 1, and the array 2 could be something like value is missing, it is 1. So 8 values in both the arrays, which are a permutation of this this array right here, all the way up till 8. Both these arrays are permutation of this. This is what we'll be working with. Now with each passing index, they want us to find the count of the values which are appearing in both. So let's say at this index right here, what is the count of values which are appearing in both the arrays? So we see a 2 appearing, a 3 appearing in both the arrays, and a 4 as well. So if you take a look, what we are basically doing is an intersection up till this index. We are doing an intersection. We take an intersection of both these, convert this subarray that we got and this subarray that we got to a set, and do an intersection. This is what we'll be getting: 2, 3, 4. The order could be anything, but we are only caring about the length, the count of values. This is basically nothing but the count of values which are appearing in both the arrays up till this point. So up till this point, the answer will be 3. So what I'm trying to do is, what if we define a set for both these arrays, set 1 and set 2, and with each passing index we keep on adding values and do a quick intersection of both these sets. So at index 0, I'm going to add a 4 here and a 2 here. We do the intersection. The answer will be empty set because again there are two different values. So at the 0th index, the answer will be 0 because we have got an empty set. Then we will come at this index right here. We'll add a 2 here and we'll add a 3 here. The intersection is going to be this common element 2, and the length of the set will be single digit 1. So answer will be 1 for this index. Now we come to the second index, which is this one right here. We'll add a 3 here and we'll add a 4 here. So 2, 3, 4, 4, 2, 3. We see that the intersection is going to be this set again, 2, 3, 4. The length will be 3 common values. So the answer is 3 at this point. Now we come at the fourth index. We add a 1 here and a 8 here. So we have 1, 2, 3, 4 and 2, 3, 4, 8. So again the intersection is 2, 3, 4. The intersection is a 2, 3, 4 and the length of that intersection is 3. So we'll add a 3 here. Now up till this index 5 and 7, we add a 5 and a 7. So we add a 7 here and 4, 2, 3, 1 and a 5 here. What is the intersection? We see 2 appearing, 3 appearing, 4 appearing, and that's all. So the answer is still 3 for this time at this point. Now we add a 7 and a 6. We add a 7 and a 6. What are the common values that we are getting? The common values that we are getting is a 4, 2, 3, 7. So it means 4 values which are common in both. The count of values 4 is common in both the list up till here. How so? We have a 7, we have a 3, we have a 2, we have a 4. I think that's pretty much it. Yeah, so 4 values. So 4 values up till here. Now we come at this index, 6 and 5 getting added. 6 is getting added here, 5 is getting added here. Now let's see what common values we have. So we have a 4, we have a 2, we have a 3, we have a 5, we have a 6, we also have a 7. So there are basically 6 values now, right? You see 1, 2, 3, 4, 5 and 6. 6 values. The moment we reach the last index, we know the answer will be exactly the length of the array. Why so? Because the moment we reach the last index, you are basically including all the possible values from 1 to 8. From 1 to 8 inclusive, because it's a permutation of the bigger array that we saw. So the answer for the last index will always be 8, no matter what happens. 8 or the length of the array that we are dealing with. So this is the simple approach that we can do. The length of the array at max could be 50. That's what they have given in the test case. It won't exceed this. So if we try to create a set, the length at max the set size can go up to 50, and it won't be a very expensive operation to do the intersection. So if we do that, and then we can get our answer easily. In the end, we just need to return the length of the intersection of the set that we got so far at each index. At each index, we'll find the length of the set that we have so far, and we'll return that length in a separate result, in a separate resultant array. At each index we find the length, add the value. Each index we find the length, add the value. So yeah, let's try to quickly code this up. What we'll need is 2 different sets for both the arrays. Now we need to iterate. Also the length of the array is going to be same because they are the permutation of the same array. So they will be same, which will be from 1 to n, inclusive of both the values 1 and n. So now let's quickly do an iteration. We'll also need a resultant array which will have the answer at each index. So let's do a quick iteration. Right, now again we are adding the values from list 1 in set 1 and the values from the B list in set 2. This is our first step, to add the values. Now since we have that, we can take an intersection, and the length of the intersection, the length of the resultant set that is going to form, we'll add that length to our resultant list that we have defined here. So that can be done right here. Length of the set that will be forming. So we can basically do set 1 dot intersection set 2. This right here is going to do the intersection for us, find its length, and then append the res to it. Like whatever value we'll be getting here, we're going to append that to this res that we defined here, and ultimately we just need to return this resultants list that we are getting. So this is how the code is going to work. Let's try to run this now. So as you can see, it's passing both the test case. Let's try a custom test case as well. Let's say the length is 8 in this one, and we can take this example that we had right here. So we had a 4 2 3 1 5 7 6. All right, so we have a 4 2 3 1 5 7 6 8, and in the second test case we have a 2 3 4 8 7 6 5 1. We saw that the answer for this array was 0 1 3 3 3 4 6 8. Now let's try to run this and see. So as you can see, this is exactly what we are getting: 0 1 3 times 3 4 6 8. So this is how the algorithm is working. It's a pretty simple algorithm. We are doing the intersection at each index, and then whatever length we are getting of the set, we are going to add that to our result. Let's try to submit this. Yeah, it's decent enough, not bad for a solution. And I think we could have I think there would be a solution where we like there's no need to find an intersection between the sets, but I think since the intersection won't be that expensive, and since the length is not that much, so maybe that's why. If the length would have been greater, we could have done something better. But so far for this one, the test case that they have provided, this seems like a pretty normal problem. Now let's see the time complexity. I think it's going to be big O of n. Yeah, because we are basically doing an iteration, going through the entire length of A and adding values and then doing an intersection. So yeah, that was it for today, guys. I'll see you guys in the next video. Bye.